Hi, I'm Dave from BLOCKY, and I'm excited to show you some of our ongoing work around adding a WASM-based compute layer to our attestation service. For our demo, we'll use the Coinbase Prices API to see how we can get the average of the buy and sell prices of Bitcoin. All of the computation will occur in a trusted execution environment using a function that we will create in this demo. And while we'll not demo it today, features such as private inputs and attested computation outputs will be in our production system. We'll develop our function using Go. However, if there's sufficient interest, building tooling to help users develop functions in other languages such as Rust or Zig or Python should be pretty straightforward. If you don't know Go, don't worry. It's a very easy language, and I'll take things slow, kind of walk you through them as we come up. So there are a few panes here. On the right, we see the server running in a trusted execution environment in debug mode on Amazon Web Services. We're running this in debug mode because you can't access the console unless you're in debug mode. On the left is my computer where we're going to develop our functions. So let's start by investigating the endpoints from Coinbase. So we're just going to run curl and investigate the sell endpoint, and we're going to take the result, pipe it to JQ so we can look at it. So notice we get a JSON object with one field, data, which itself has a JSON object where there's three fields, amount, base, and currency. The only value that we're going to care about today is amount. You can notice that the actual value in amount is a string, and what we're going to have to do is, in addition to parsing the JSON, we're going to have to also parse this string into a floating point number. While we're here, we can investigate the sell endpoint, the buy endpoint, and we can notice it's, again, the same structure, same amount where it's a string. The only difference is the values of the buy and sell are different. So we're going to compute the average of those in our demo today. So let's hop over to start filling out our function. So let's open demo main. And we start off by defining our entry point. So we can call this function whatever we want to, but we have to export it. Here we export it as entry point demo. And this is actually the name by which we're going to refer to it later in the demo when we actually want to call this function. These don't have to be the same. I like to keep them the same just to make my life a little bit easier, but the name of this function actually doesn't matter. So let's start filling out this entry point function. And so we'll put in what our implementation is. And let's just put in stubs for the two items that we need. And you know what, let's full screen that so it's a little bit easier to look at. Okay, so here we define a type. This is going to be the type of the response. That's going to define the structure of the data that we're going to actually respond back to the user. We just put a stub in for the average by sell. We're going to put some implementation in here, just not yet. Now we filled in some of this entry point function where we call average by sell, where we get back two values. One is the average, the other one is an error, and then we're going to check the second value is nil or not. If you're familiar with Go, you're kind of seen this pattern before. If error does not equal nil, then that means we had an error, and then we're going to process the error path, or we get back a value. Right? So this is kind of how error handling tends to be. It's a little bit verbose, and that's kind of one of the things that Go is known for, but relatively easy to manage. So you kind of see this pattern a bunch today. Okay, so if we did get a value, it's this average value. We're going to take our response type. We're going to wrap average in this response type, and then we're going to emit this result. So this emit result is a utility that we provide that prepares the output of the function to send it back to the user. Okay, so now let's kind of just dig in and write this by sell function. And you're going to have just some errors right now, so let's put in a stub for that one. Okay, cool. So for our buy sell, we're going to kind of set our Coinbase the URL, kind of the base of it. So this is, if you remember, all of them had this as the prefix, and then it was /by or /cell. So we're going to define this function, which eventually is going to do all that, get the data from Coinbase, parse it, return back the value, kind of get these amounts. So we call it with the buy, we get the buy amount, again do this error checking stuff, and then log the buy amount. Do the same thing for the sell, do some error checking, log the sell amount, and then compute the average. So similar to emit result, this log function is something that we provide. Since not all trusted execution environments support console logging, this function makes it a lot easier for a user to develop a function within the context of a trusted execution environment. We'll kind of see this in a little bit when we run through this actual execution. And so finally, let's flesh out this get amount from Coinbase example. So the first thing that we're going to do is define a type to put our response back. This, if you remember from when we were looking at the data from Coinbase before, this should follow a very similar structure. Right? There was amount, base, and currency. We only cared about the amount. It was a string. Right? So kind of the same structure to like parse this thing. And now we'll put in an implementation for get from Coinbase. Okay, so let's go through this. First, we call this HTTP get function with our string. We'll talk about this a little bit more in just a second. And then if there's an error, we do the error dance. This will parse that response into our type. So right, unmarshal is kind of like think deserialize if you're familiar with other languages. So this pulls this data in. And then remember, it was a string, so we have to parse it from a string into a 64-bit floating point number, which is what this line does. Again, do some error checking, and if not, return the amount. Okay, so now putting it all together, right, we make our HTTP request, we parse the data, parse the floating point number, return the amount, and then we just do this twice, getting our average. Okay, so I said I would come back to this get HTTP, or HTTP get function. So similar to emit result and log, HTTP get is a function that we provide. So because WASM and some trusted execution environment platforms do not directly support HTTP requests, we provide this function to make it easier for you to develop new functions with web capabilities. The details of how we actually do this kind of would fill up a video unto itself. So there's the short version is that we make a channel where the HTTP get request goes out from WASM, then goes out through the trusted execution environment, and then we kind of walk that backwards through back into the trusted execution environment, and then bring it back into the WASM runtime, and then kind of extract the bytes and then give that back as the response. Okay, so next, we're going to compile this program into WASM using TinyGo. To do so, we're going to run the following command. What this does is use the TinyGo compiler to build our WebAssembly. Right, so the output is going to be demo.wasm. We're setting the target to be WASI. We're going to compile it without debug information. And then we're using all the files in this directory. Okay, so we'll finish off our demo by running our function in a trusted execution environment. We're going to use a simple program that just forms a payload for an HTTP request, consisting of the WASM function for the WASM that we just compiled and the entry point function. So we'll go run main.go client. So this is the information for the program that we're running. This is the file that we just compiled. So this is our WebAssembly, and then this is our entry point.demo. And so now we're going to run our function. Awesome. So we ran our function and we got back time. So this time value is the wall clock duration for the function invocation in the TEE. So basically everything in this time that was not this 351 milliseconds was latency from my computer. The body value here is the response that we got back. If you recall, this is actually what was coming out of this emit response or emit result. value. And so this is actually what the average that we computed was. Other things, if we hop over to kind of our server that we were looking at, we have these two logged values that were the two values that we actually computed the average from. It just so happened that at this point when we called it, the buy amount and the sell amount were the same value. And we took the average of them. We got our value. So in the future, we plan to actually package up these log messages and just send them back to you instead of logging them over here, so that you can use this kind of for development and debugging, whatnot. So that's about it. I hope you've enjoyed this demo and keep an eye out for it on production, as well as some additional features such as secret inputs and tested outputs. So please reach out if you have any more questions, and have a great day.